So in this video, I'll be talking about how to solve for some simple ratios without using a calculator in trigonometry. So before we get started, let me just first explain what these two are. So these two are right angle triangles and they have specific angles that make the ratio of their sizes significant. So in this triangle, this is called a 30, 90, sorry, not 90, 30, 60, 90 triangle. And so what that means is that 30 is this degree over here, and 60 is this degree over here, and obviously 90 is over here. And over here, this one is called a 45, 45, 90 triangle. So these triangles have specific angles, and as I said before, no matter, let's say, how big or small they are, let's say a triangle, a right angle triangle is this small, but they have the angle 60 degrees and they have the angle 30 degrees and they have a 90 degrees, then the ratio of their sizes, so this side here and this side here and this side here, are always going to be the same. So it's always going to be 2a square root 3a, and not square 3a, or you can say square root times 3a, or I like to do it the other way around, a squared 3. Actually, I'm just gonna replace this as a squared 3. Yep. And this is going to be a. Of course, if you rotate it, and like for example, if you rotate it and make it like this, and if this is 60 degrees and this is 30 degrees, the ratios will also be the same. So this is going to be 2a, this is going to be a, and this is going to be a squared root 3. And so no matter how big or small these triangles are, the ratio of the sizes are always going to be the same. So here, let's say we have sine 30. It says, it says first, find the values of the following ratios in simplest radical fraction form, radical or fraction form. So before we get started, because we have some unknowns here, we have a, 2a, and then we have also another a here. We also have a here and a here and an a there. So I don't want that. It says simplest radical form or fraction form. And so I'm just going to say, let's say a is 1. So if I replace a as 1, this means that this is 2 times 1, which is just 2. And this is 1 times square root 3, and that's the same as square root 3. And again, I have 1 here, and square root 2. And so that is really simple. And so the first thing here, let's say we start with this one. The first thing we want to do is identify which one of these triangle are we going to use. So it says sine 30. So which of these two triangles, either this triangle or this triangle here, has an angle that is 30 degrees? Well, it's the triangle on the left, because as you can see, there's a 30 degrees here, a 30-degree angle here. And so we're going to use this. And it says sine 30 degrees. Now, remember, we have something called SOHCAHTOA. And so opposite means, not opposite. O represents opposite, H represents hypotenuse, and A represents adjacent. And so sine is SO. And so that means it is, because it says 30 degrees, so we're trying to focus on this angle here. And so it's opposite, see, it's OH here. It says OH, so that means opposite over hypotenuse. And so the opposite of 30 degrees is 1, or A. I'll just write it out as 1 over the hypotenuse, which is 2. So that is the fraction form. And we want to do the radical form. Actually, we don't have to do the radical form. It says fractions form, so we can just leave it as a fraction. So it's really that simple. Now let's move on. We have cos 60 degrees. Now again, the first step we want to do is to see which of these triangles are we going to use. Again, it's the triangle on the left because we have an angle of 60 degrees over here. And so this time, instead of using SO, we're going to use CA because it's cos 60 degrees. Now, A means adjacent, and h means hypotenuse, so it's adjacent over hypotenuse. And so remember, adjacent is something that is close to you or sticking right next to you. And so we know that this is not adjacent because we know that this is definitely the hypotenuse because it's the longest one. And we know that the adjacent is a here. And so that, again, it is 1 over 2. Now this time it is tan 45. Now again, we want to know which of these triangles has an angle of 45 degrees, and it is the triangle on the left. Now, this time instead of using cos, we're going to use TOA because it's tan. Now notice that we have two different angles here. But if you take a look at that, that just means that these two sides are the same. It's an isosceles triangle. So it doesn't matter if you do it this way or you do it that way. It doesn't matter. So I'm just going to do this way. And so tan is OA, so opposite over adjacent. So opposite is 1. Over adjacent is also 1. So it's going to be 1 over 1, which is equal to 1. And so it's that simple.